Hey Sanity friends! Today I want to share with you 3 approaches that I use for generating ranked lists of related content using taxonomy terms managed in Sanity Studio. Approach 1, tag count. If you add tags to your Sanity documents as references and an array, Sanity already gives you a way to check to see if those 2 arrays have any overlap. That's the array intersects function. And it's pretty good for finding where arrays match, but it's not very good for ranking content because it doesn't return a number. In order to do that, we're actually going to add a new attribute, shared tags. We're going to count the number of unique items in both arrays and then subtract that number from the total number of items, which is to say we're going to remove the unique items from the combined arrays, which will only leave us with the duplicate items, shared tags. And that gives us a number that we can then order in our results to give us the resources that have the most tags at the top and the resources with the fewest tags at the bottom. So this is an improvement. We can now rank our related resources based on how many tags they have. If all of your resources have the same number of tags, you're probably done. But if you have some resources that have more tags than others, you're going to find you get skewed results. If I have resource A that has 10 tags and 2 tags match the parent resource, and resource B that has 2 tags, both of which match the parent resource, the relationship of these 2 resources to the parent isn't the same. Resource 2 actually matches much more closely because it doesn't have all of those other topics associated with it. This brings us to approach 2, relatedness. In order to move from the raw number of tags in a resource to how related 2 resources are to each other, we're actually going to take the average of the number of shared tags against the total number of tags in a resource. And this is a pretty simple calculation. I'll add a new projection to our query here. And in this one, I'm adding the value relatedness, which is our shared tags multiplied by 2, so we get the total number of tags, divided by the length of the combined parent and related resource array. This gives us a number between 0 and 1 that represents the percentage of how many tags are shared, a more precise relatedness than simply shared tags alone. So we can see here in this first resource that my second and third related resources have 3 shared tags between them, but the first of them is 75% related, whereas the second is only 67% related. So this allows for more precise ordering in my related resources. You might find, however, that precision doesn't always get you all the way to your goals. This brings us to approach 3, curation. There may be some instances where you don't actually want your content to show up in the exact order of relatedness that we've defined here. Maybe you're running a campaign, or maybe you have a particular initiative where you want to boost some content or want some other content to be a little lower down on the hierarchy. In this case, since we have a relatedness value between 0 and 1, we now have the opportunity to provide a defined value to either boost or drop down a particular class of resources. To accomplish this, I'll add a third projection in which I use this select function to identify which insight types are case studies, and then I add to their relatedness score a case study boost, in this case 0.2, and I'll also identify which insight types are interviews, and actually I want to drop their value down by 0.1. Anything else that's not one of those types, the value gets passed straight through. This then allows us to curate how different resources are ranked within our related resources array that's returned. And we can see in some instances where this actually reorders the related resources to put one type in front of another. This last approach illustrates one of the benefits of separating your content structure from your content semantics. You'll notice in this query that I actually only have 2 document types, an article and a case study. And these are separate document types because they're structurally different. But there are 4 insight types that I use to classify this content and that I use in this query in order to boost or suppress certain types of content. Those insight types are managed in a very simple taxonomy in Sanity Studio. This means that I can express the semantic differences between my insight types without having to create new document types in Sanity or hard code values into my content schema. It also means that I have a single source of truth for my content semantics that can evolve over time as my content needs change. So there you have it, 3 simple approaches for creating ranked content lists from your Sanity content store. To learn more about managing your organization's content semantics and taxonomies in Sanity Studio, check out this Sanity Taxonomy Manager plugin on Sanity Exchange. Likewise, if you'd like help designing and building a well-structured and semantically sound content model for your organization, please do get in touch at andyfitzgeraldconsulting.com. I'd love to hear from you.